Hi everyone. Today we are going to discuss about a example problem for conversion of regular expression into DFA using the Thomson construction method. So as discussed, for Thomson subset construction you will be having two steps. The first step is to convert the regular expression into NFA, and second step is need to find the epsilon closure, and then you need to find the transition function. So coming to the first step, so this step 1 represents the conversion of a regular expression to NFA. So the expression given is a slash b whole star. So this is the diagram which converts the regular expression into NFA. And after converting the regular expression into NFA, you need to find the epsilon closure. So first is that we need to find the epsilon closure for the starting state. Here the starting state is 1. So here which represents the epsilon closure of 1. So from 1 self state, from 1 you will be having a transition function which is moving to 2, and from 2 you will be having two transition functions with the empty transition which is moving to 3 and then 5. So we have represented 1, 2, 3, 5, and from 5 will be having an epsilon transition which from 1 which is having epsilon transition which is moving to 8. So the epsilon closure of 1 is 1, 2, 3, 5 and 8. So after step 2 will be moving to step 3, which is nothing but the transition function by applying the input symbols. So you will be having two input symbols, one is A and the other one is B. So the new state which is found is represented using capital A. The states are the state which having the input symbols as 1, 2, 3, 5 and 8, which is represented using the capital A. Next step 3, which is nothing but transition function. So you will be applying the transition function with input as small a. So epsilon closure of move of capital A, and then with the help using the input symbol small a. So for this one we'll be having the output as epsilon closure of A. So the epsilon closure of A is nothing but 2, 3, 4, 5, 7 and 8, which is a new state which is marked as B. So we have completed with the transition using small a. Now we are proceeding with the transition using small b. So for transition using small b, we will be having epsilon closure of move of a comma b. So for this the epsilon closure of move of b is 2, 3, 5, 6 and 8, which is also a new state which is marked as C. So we have completed with epsilon closure of apply transition function for capital A state using the input symbols a, small a and small b. Now we need to apply the input symbols small a and small b for the new state B. So here is the representation transition function of b comma a. So here is the epsilon closure is after applying the transition function for b comma a, the epsilon you will be getting the epsilon closure of 4. Epsilon closure of 4 is nothing but 2, 3, 4, 5, 7, 8, which is nothing but here the state B, which is an existing state. Now coming to b comma small b transition, again we are having an epsilon closure of 6. Epsilon closure of 6 is nothing but 2, 3, 5, 6, 7, 8, which is nothing but the state C, which is an existing state. So we have completed with transition function for A state, B state. Now we need to proceed with state C using the input symbols small a and small b. So first transition function of C comma A, which is nothing but epsilon closure of 4. Epsilon closure of 4 is nothing but 2, 3, 4, 5, 7, 8, which is nothing but the state B, which is an existing state. And finally transition function of C with small b, which is nothing but epsilon closure of 6. Epsilon closure of 6 is nothing but capital C state, which is also an existing state. So we have completed with state A, state B and state C. There is no more new state. And step 4 is we need to construct the transition table. So for transition table you need to, the row will be the new state, which is nothing but A, B, C, and column will be the nothing but the input symbols small a and small b. So will be start, you need to mark the new state, starting state, which is nothing but a. So from a, for a input symbol you will be moving to transition b, and for a capital A, for small b will be going to C state. Likewise we need to mark for B. For B state with the input symbol small a will be going to again B. For B with the small b input symbol will be going to state C, and we again finally will be representing for C also. So this is the transition table, and for a final state will be marked, you need to mark the final state. So in the transition diagram we'll be having the final state as 8 for from RFA to NFA conversion. So this 8 number is appearing in state A, state B, and state C also. So for because of that we need to mark capital A, capital B, and capital C, all these three states as final state. So this is why we'll be marking star in all the three new states. Step 5 is we need to construct the transition diagram for this transition table. So this one shows the transition diagram for this transition table. So if you look into this transition table, for states A, B, and C, for all the input symbols, for A you will be moving to, for all the states are moving to the next state as B, and for small b input symbols it is moving to the next state as C. So it means A is equal to B and B is equal to C. So we can club all these three states as one, as shown in this second diagram. Here you will be having a single state as A and input symbols as A comma B, which is moving to having the self state. So this is how we will be converting the regular expression into DFA using the Thomson construction method. Thank you.